Hello everyone, welcome to my first live presentation here. My name is Maliheh Sefat, and today I'm going to present to the first few chapters of the Quick Python book by Mahdavi. This is the final task of step 1, machine learning paths from the CS internship program. As you know, Python language was created by Guido van Rossum in 1991. There are many videos of him and about him available on the internet that you can watch. This here is his personal website, and this is the Python organization website that you can find downloading packages there and stuff. So why should we learn Python? Python is very good for a large number of programming problems. Python is suitable for learning to program, like me, and Python works well in cross platforms, Windows, Linux, etc. Python is very good for small applications, rapid prototypes, when you want to show your idea quickly. And Python has a good graphical user interface, GUI. Python enjoys vast number of libraries, handful in various programs, and Python is free. So, what does it mean that Python is free? Python is what is called free open source software, or FOSS in short. It is not only free of cost, but also free to use, free to modify, free to improve and extend. Why? Because the source code is available, and you are encouraged actually to improve and extend libraries and applications. And it is also recommended that you contribute to the community, either by donating money or by sharing what you have improved of libraries and other applications. Actually, open source movement is a very interesting topic to study and search. So, what Python does well? As we said before, Python is very easy to use. One reason is that types are associated with objects, not variables. This means that variables are flexible. But it has its downside that the programmer is responsible for checking the variable data type. Python has much higher level of abstraction. Syntax rules are very simple, like a simple def defines a function. Python is expressive. A single line of Python code can do more than a single line of code in most other languages. You know that when you see it. Why this is good? Because the fewer line of code there are, the easier the program will be to maintain and debug. You can easily locate a bug when you see the program in front of you in a few lines. Python is readable. There is no ending semicolon or curly brackets delimiting the block of codes. Python is complete because it has libraries that you can import just by the import statement. You don't need to install any extra library. As we said, Python is cross-platform and also free. What doesn't Python do as well? It is true that Python is not the fastest or the vastest language there is, but we love it anyway, despite its flaws. Why learn Python 3? Because it's the latest version that is going to expand. One obvious or one most important difference between Python 3 and other Pythons is the print statement. Print is function here and goes inside parentheses. This is the summary we skip. Installing Python is the chapter 2, so we go to python.org/downloads. The latest version when I went there was 3.12.2.2. Installing Wizard of Python is like this, and uninstalling Wizard, if you accidentally uninstall, gives you some other options too, like repair and modify. Installing IDE. You can easily use terminal or shell in your device to test Python codes and even develop a complete Python application and push it. But it is recommended to use IDEs. IDEs give extra options and functionalities. The book recommends IDLE, but I had already Sublime Text installed. And the Jupyter Notebook is very good. It gives you the option to execute block of code cells individually. And in my experience, Jupyter Notebook is very good for teaching programming, teaching Python. And this is an example of a few lines. When you save the file with .py extension, it goes colorful. This colorful is not just a look, it gives meaning. It's according to the syntax. You see here, self is orange, if is pink, and so on. And it also has other functionalities that I'm going to learn later. Summary we skip. Chapter 3. As you see, chapter 3 is an overview of all the important topics in Python, and I know we are not going to get enough time to explain all of them, but I try to point out some important pro tips that I believe we should know. Python 3 Chapter 3 starts with the data types. Data types are generally categorized in two categories, mutable and immutable. Lists, sets, dictionaries are mutable. And numbers, strings, tuples are immutable. Immutable means that you cannot change them and modify them after they are created. But mutable data types are changeable. Numbers are immutable. There are four categories of numbers: integers, positive, negative, correct numbers. As we know, floats have decimal points. Complex numbers have imaginary point shown by the J notation, and booleans, true or false, that is which is used in logical calculations. We can work with operators such as explanation, division on the numbers. this was the important part for me. I believe that every new programmer like me should get familiar with the terms and names of in the programming field, such as operator, operand, attribute, function, method, module, etc. You see, operators are what we seen before: addition, multiplication, etc. We have two kinds of divisions in Python. Attributes are variables associated with an object and are used to store data related to that object. This part was important for me. I highlighted it. You see here, x.real is an attribute of the x, an instance of the class Python, which returns the real part. And here you see an example of built-in function, round. Rounds the number, a float number to its integer, rounds it down actually. And modular functions are written like that: module dot function, and the arguments go inside parentheses. We here import math module and module dot cil rounds the float number up actually. So another data type is lists, and lists have the slicing option. You can slice with this slice notation and do various calculations on lists. Lists have two options for indicing: positive indices, negative indices. Positive starts from the left hand side with a 0, and negative starts from the right hand side with -1. Here it was important for me again, methods. You see we have built-in function len here that gives the length of a list, and operators which don't change the original list. The slice notation changes the list, and here is an example of method. x.reverse reverses the x. Methods are functions that are associated with an object. They are used to perform operations on the object. So, and the next data type is tuples. Tuples are much like lists, but they are immutable and they go inside parentheses, and one item tuple needs a comma. So we can we can make a list of a tuple or a tuple of a list. Strings are also immutable. They go inside quotations, and there are a lot of options for that. Single quotation, double quotation, triple quotation, and they can contain tab and new line characters. /t/n show the new line, and tab. You cannot just tab inside the string or enter for new line. It won't work like that. When you want to use a single quote, and when you want to quote a part of a string, you have to use different quotation marks for that. This was apparently more important for me because I repeated it. X.split is a method that works on the string, and it splits by a space, empty space, and it gives returns a list of the words. You can give arguments like comma, and it would split the string by comma. And this here operator, I don't know, percent sign or modulo sign, is used as a placeholder, and we give the actual items, actual variables later. Dictionaries are also immutable, and a dictionary in Python provides associative array functionality, such as names and last names, names and age, or cities and countries. They are related to each other, associated to each other. And you see here a method of x.get. You give it a key, a list dictionaries are can the value